Welcome to the AWS Summit Online and this talk in our Startup Founders track on productionizing your proof of concept. My name is James Ousby and I'm a Principal Solutions Architect with AWS based in Sydney, Australia. Currently I'm part of the independent software vendors vertical, helping some of Australia's homegrown success stories like Atlassian and Canva get the best use of the AWS platform. This is a Level 200 talk about how you can quickly build out an operations and analytics capability around your product on the AWS platform. In short, we're going to talk through an opinionated solution and the technology choices behind this solution. Then we're going to follow this up with a demo that shows some code and how it all hangs together in the AWS console. So here is a scenario that I hope you have either experienced or are hoping to experience soon. Your team is executing well on a great idea, you are winding up on the latest sprint review, and the demo of the current build looks like it ticks the box for a minimum lovable set of features. Your non-technical founder leans across the table, fist bump, let's ship it. However, as the technical founder, you know that there's still a lot of duct tape under the covers and a lot more elbow grease required to get the product into really good shape. What are some of the things that you are thinking about when looking to make a call on when you are ready to ship? There are good reasons why you might want to launch earlier than you perhaps feel comfortable. The main reason you're probably thinking about is that of early customer feedback. As popularized in books like The Lean Startup by Eric Ries, getting early customer feedback by finding innovative ways to test what features or products a customer really wants allows you to make data-driven decisions early on about how to make the best use of your startup capital. Similarly, AWS talks a lot about how customer feedback forms a key part in our continuous delivery, continuous innovation flywheels. AWS services will often launch with a minimum set of features for a specific set of customers, and then we let customer feedback drive further product development. We don't try to second guess in advance what most customers will find important. So, we want to launch as soon as possible to start the customer feedback flywheel. But we want to make sure we are on the right side of scrappy when we launch. We don't want to risk our company's reputation, our customers' data, or squander the early opportunities to earn customer trust through a good customer support experience. You need to decide what is the minimum bar you want to set for the build and operations of your product before you launch. On the left-hand side here, we have some of the areas you'll want to think about when deciding where that bar should be. The first thing is security. We won't be talking about the security mechanisms you can put in place around your product in this talk. For this, we have a great talk in the InfoSec track, identified as SecO 1, the simplest security steps for AWS. This talk outlines the core security services and principles you can apply to feel comfortable that you have addressed the basics in securing your system against unauthorized access. The second area to think about is that of observability and analytics. You lose some of the benefit of launching early if you don't have the tooling in place to collect the data from your first experiments or customer interactions. However, at this stage, you are unlikely to want to invest a large amount of developer effort into building a solution in this space. This is what the solution I'm about to present to you today will focus on. Finally, there is obviously a number of other dimensions on which you may form an opinion as to how much you need to address before you go live in production. Personally, I don't get out of bed in the morning without a CI/CD pipeline, but there are many successful startups who have got started without full automation in their delivery process. A lot of these dimensions your customers may be more forgiving on and can be evolved over time. So what follows is an opinionated solution that leverages fully managed services from AWS, some of which are relatively new, to put a sophisticated observability, operations, and analytics capability around your product. The high-level solution goals are: put a monitoring solution in place that detects when your platform is having issues. Minimize the disruption to your development team by only alerting the person in your team that is currently rostered on for the support role. Empower your rostered on support person to easily investigate product issues and customer support requests. Where you need to make code changes to support these goals, Do so using open standards that allow you to evolve your architecture over time. And until you invest in an analytics platform, what is a low investment method for capturing and analysing platform activity? Let's start with your core product. This is the secret sauce that you've been working on and are now ready to put in front of customers. For the purposes of this talk, it doesn't matter what your product architecture is, whether that be monolith versus microservices, containers versus serverless. What we are focusing on today is the layer we build around this. In this demo, however, I have two microservices, an order service and a user service. Each service has its own REST API using AWS Application Load Balancer as the front door. Amazon Elastic Container Service as the means of running my compute, with Amazon DynamoDB as the backing store. For other ideas for your product architecture, I encourage you to check out another talk in this track, SUP 03, Deploying a Surprisingly Simple Architecture for Your Early Stage Startup. The first thing we are going to add is a monitoring capability. Amazon CloudWatch Synthetics was released at the end of 2019, and it allows you to continuously check if your API or web page is available and healthy. In today's demo, we're going to look at polling the get/order API endpoint every 5 minutes to see if everything is okay. Next, we're going to look at what happens if Amazon CloudWatch Synthetics finds that there is a problem. At this point, we want to notify someone in the team so we can respond quickly. But ideally, we try to keep the disruption to the wider development team to a minimum so they can continue to focus on product delivery. AWS Commander is a new service from AWS that allows you to find a team support roster, and when an alarm is raised, notify the current on-call support person with the alarm details. Amazon CloudWatch Synthetics and AWS Commander is an exciting new combination. Next, we want to work on enabling the on-call support person to effectively diagnose and remediate the identified issue. This starts with instrumenting your application to generate a useful set of logs, metrics, and traces to analyze. The open source project OpenTelemetry is an exciting initiative looking to standardize how applications generate observability data and allow you to easily move or migrate to alternate downstream observability platforms if you so need. AWS is investing heavily in the OpenTelemetry community with their own AWS distribution for OpenTelemetry that we will talk a bit more about later on. Next, we capture those logs, metrics, and traces in an observability platform so our on-call support person can analyze them. Specifically, we will be using AWS X-Ray to capture all the traces our application generates, and we will be using the CloudWatch family of products, logs, log insights, metrics, and dashboards to make sense of the log and metric data that we generate. Additionally, we talked to the idea of putting a simple analytics capability in place to analyze the data for any experiments we run or general business KPIs, like number of customers per day or dollar value of new orders. Until you prioritize building an analytics capability, you can leverage CloudWatch Log Insights and CloudWatch Dashboards to give you a pulse on how your product launch is going. And we will have a look at an example of this in the demo. Finally, with our monitoring and observability layer in place, we are now ready to start accepting customer traffic. In my 20 years of software development, I've never once launched a new product with this level of capability in place from day one. Too often, the capabilities we are discussing today would be backlog items that we would deprioritize for another day. I'm really excited about what a small team can put in place on day one now with a small amount of investment. We covered a few services and ideas in our solution walkthrough fairly quickly. Let's dive into each of these capabilities in a bit more detail before we have a look at the demo. So for our monitoring solution, we discussed using Amazon CloudWatch Synthetics. This service allows you to run a non-trivial health check of your API endpoints or web pages on a regular cadence, provide custom code for checking the results, capture the logs of each call, and capture snapshots of web pages. Critically, don't let your customers be your health check. Ideally, you find out about issues before they do and can be proactive in your response. As you can see in the screenshot, the service allows you to visualize the historical results of these checks and generate a high-level availability number. Off the back of failed calls, you can trigger CloudWatch alarms to drive automated responses. It's possible to define endpoint monitoring using infrastructure as code tooling and make it a part of your template when you provision APIs. For actioning alarms that are triggered by CloudWatch Synthetics and lots of other sources, we have the new AWS Commander service. It allows you to define a team roster along with their preferred contact methods. It then allows you to assign these contacts to a response plan that is executed when an issue occurs. This allows you to both ensure you get a fast and appropriate response, all while keeping the interruptions to the rest of the team to a minimum. Additionally, it provides the ability to manage and document the outcome of an incident so you can review and improve your service over time. Central to our opinionated solution is the ability to observe our product once it goes live, in order to make data-driven decisions about future product direction and to support any operational requirements we have. 10 years ago, writing and capturing logs was pretty much the only method that application teams would apply for observing a live system. Since then, the field of observability has evolved alongside new architectural patterns like microservices that necessitate a more nuanced approach. Today, when people talk about observability, they're usually talking about three core pillars: metrics, logs, and traces. Pick any programming language and you will usually find a variety of choices for frameworks or tooling that let you add logging, metrics, and traces to your code. Some, like Java, have a de facto standard in SLF4J that the tools for that language conform to. OpenTelemetry is a wildly ambitious project that is looking to standardize the production of logs, metrics, and traces across all programming languages, with 11 supported languages and growing. In a world of distributed microservices that may vary by implementation language, this is a huge win. It's also a boon for observability platform providers that can standardize on the ingestion formats that they support. OpenTelemetry is a cloud-native compute foundation project with multiple industry supporters. One caveat I should mention is that as of April 2021, OpenTelemetry does not provide language support for generating logs, just metrics and traces. The log specification is still under review. To set the scene for why AWS is investing heavily in OpenTelemetry, it's worth understanding our position on open source in general. Our customers love open source and ask us to help them, which drives us towards open source. We contribute to projects that matter to them and help support innovation. At times, it is pre-existing projects that are meaningful to our customers, like Linux or Kubernetes. At others, we innovate on their behalf and proactively open source, in the example of AWS Firecracker. At times, we also contribute to our customers' open source projects, like the Netflix Spinnaker project. Healthy communities are important to the longevity of open source software that our customers consume. And therefore, we continuously look to increase our support of those communities in a variety of different ways. Many open source contributions bubble up from within our teams as it helps them reduce technical debt and reduces maintenance burden. And in many cases, we can also increase quality and security. For example, it was also beneficial to get eyeballs on S2N, our Apache 2.0 licensed TLS implementation. In these various ways, we contribute to make open source better for AWS and for everyone. But in addition to the work we do to contribute code, help open source companies, etc., it is also critically important that we make it easier for developers to access and use that code. AWS now has more than 175 fully featured services. Some of these have been built to operationalize open source projects, making it easier for customers to benefit from open source innovation. Others, like AWS Lambda, rely on homegrown AWS technology that we've open sourced, like Firecracker. In both cases, we actively contribute to make open source code better to serve our customers and the broader community. Which leads us to AWS Distro for OpenTelemetry. AWS has contributed to OpenTelemetry for some time. However, over the past few months, we have significantly increased our commitment to OpenTelemetry, as revealed in Code and People. Among other things, we have hired Jana Dogan, who spent years at Google working on the Go programming language, while also a key engineer on Google's Spanner database. She joined AWS, in her words, so that she could devote more of her time to writing open source software, specifically in the area of observability, working on projects like OpenTelemetry. Even before Jana joined, however, AWS submitted hundreds of pull requests upstream and have dozens of engineers working on OTel. If you are looking to start a new project on AWS, then it's worth considering making the AWS distro for OpenTelemetry a foundational component. You will be well placed with future AWS service integrations and have an easier path to changing your observability platform if required. Regardless of how you create logs, what you log is just as important, which leads us to the concept of structured logging. Applying a structured format to the log statements you create, and in the case of AWS, we are talking about JSON objects, allows you to query and analyze your logs by the named fields in your downstream log aggregation platform. In this demo, we are using CloudWatch Log Insights, which has the ability to discover named fields within your log statements if you are using a JSON structure. In short, put as much context into your log statements as you can and use a JSON structure for your log statements. There are language-specific libraries to help with achieving this. So we touched on this briefly in the previous slide, but in more detail, Amazon CloudWatch Logs Insights is a relatively new tool that lets you run a SQL-like query language across multiple log groups. So we can use this to find the logs relevant for a particular incident, along with analytical use cases like counting the number of successful orders that have been placed. However, we aren't going to want to build and run queries in Amazon Logs Insights every time we need to understand what is happening in the platform. With Amazon CloudWatch dashboards, we have customizable home pages in the CloudWatch console that you can use to monitor your resources in a single view, even those resources that are spread across different regions. Using CloudWatch dashboards, we can build operational dashboards that visualize or show the raw outputs of Log Insights queries for both operational use cases and analytical use cases. For the analytical use cases, it's worth highlighting that building this information off of your logs may not be as accurate as running queries on your source of truth data store. But the fidelity here should be good enough for making data-driven decisions when you are first getting started. Finally, the last piece of the observability puzzle is how to visualize and analyze your generated traces. For this, we are using AWS X-Ray. AWS X-Ray can take your OpenTelemetry generated traces and visualize them to make them easier to explore and reason about. In this example, where we have a Lambda function calling to S3, the trace visualization has highlighted in orange that it is the last step in the trace when the call to S3 is made that appears to have a problem. In a complex microservice architecture with lots of services involved in supporting a single operation, this type of information is invaluable for short-circuiting the debugging process. Okay, let's take a look at some of these concepts and services in action. So let's have a look at the demo. The first thing I'd like to show you is the project structure. So my demo project is a TypeScript project. It's a multi-module project. I've got 4 modules here. Order functions is the business logic for my API. So this gets packaged up as a Docker container. Order API is the infrastructure as code for provisioning that Docker container on the AWS platform behind a load balancer running on ECS. And then the traffic generator module is a tool I use locally for spinning up some traffic to send against that API to generate some interesting logs. And then the pipeline project is an infrastructure as code project for provisioning my demo on the AWS platform. But first things first, let's have a look at the monitoring solution. So we talked about using CloudWatch Synthetics for monitoring my API. Here's the definition for the canary that I stand up. It's making use of this Lambda function to query my API every 5 minutes. And if we have a look at what that looks like in the console, we can see here under the CloudWatch Synthetics tab in the AWS console that my canary is running every 5 minutes, and for the last 3 hours it's been passing successfully. I can jump into that particular canary and have a look at what it's doing every 5 minutes. I can have a look at the logs that come out from each call, along with the request and response headers. And moving on, we talked about what do we do when CloudWatch Synthetics detects an issue. So this is an introduction to the new AWS Commander service. It starts with your list of contacts. So you add the team members that you have and their preferred contact method. Next, you create an escalation plan that builds an escalation tree for the contacts you've created. So in this one, I have myself as the on-call support person. I have 20 minutes to respond when an issue is raised. If I don't respond within that 20 minutes, it goes to stage 2, which you may have the rest of the development team set up. And you can have multiple stages after that. You could have the manager, CTO, etc. Next, we'll have a look at the response plan. So a response plan is the process that you go through when an incident is raised. And critically, you'll see that I've got my escalation plan attached to this. So when an incident is raised and someone triggers this response plan to process it, the escalation plan that we just created will be executed. Additionally, you can set up a runbook that has the steps described for how you want to process a particular incident. And then finally, if we have a look at the incident management piece. So a new incident is detected either automatically or manually. I can choose that response plan for how I want to respond to the incident. Click Create. At this point, I have an in-flight incident. My escalation plan will have been escalated. I've come in and I'm responding. I can capture any of the details of the incident. And then finally, when I close the incident, there's a really nice path for documenting the outcome of an incident and improving your service over time. Next, let's have a look at how you instrument your application with OpenTelemetry. So we mentioned that as the on-call support person, I need an effective way to investigate my application, exploring logs, metrics, and traces. So OpenTelemetry, there's two main parts to it. There's a client which you configure in your application code, which you can see here in tracer.ts. And a collector which runs as a sidecar to my Docker container to collect the outputs of the OpenTelemetry client. And we have a look at how I'm using this in my code. I'm going to create a trace here which starts with the concept of a span. Span opens the trace. I can have subsector spans, and then I can close that main span at the end here. And if we have a look at what that looks like in the console, we'll jump into the AWS X-Ray console. So here you can see all the traces that are run on individual calls against my API. And this is probably going to be my first protocol investigating an issue. I can go to the service map and see a high-level summary of all my traces. So it's showing the last 5 minutes at the moment. We'll jump to the last 3 hours. And immediately we can see that for the create order function, there's been some errors recorded. And I can jump into those traces, group them by root cause error, and this can be a really quick way for short-circuiting the issue discovery process. So I'm finding that I've got some errors and there's a bad request involved. And we compare a bad trace with a good trace here. Here we jumped into a bad trace. It was only one segment. If we jump into a good trace, we can see that there's two spans here as part of my trace, the create order and the DynamoDB call. Let's have a look at structured logging. So in my code base, I've got some code here for helping you do structured logging in a fairly simple way. I've got this function at the top that captures my log message in a JSON structure with a particular set of fields every time I run a log statement. And if I have a look at how that looks in my code when I use it, it still looks very much like how you would normally do log statements. I've got my normal message and a payload attached to that. But the neat thing about using this structured logging approach, if we jump into the CloudWatch console, is that I've got a particular set of fields captured that you can use for analysis. So here we're in CloudWatch logs. I'm going to open up CloudWatch logs has a concept of log groups and log streams. So we're going to jump into a particular log stream here. And you can see that my structured logging approach has created a fairly wordy log statement here that's got the details in a JSON object. And at this point, it's not particularly useful. So I've got perhaps multiple log groups, multiple log streams. How do you make sense of that? That's where CloudWatch Logs Insights comes in. So CloudWatch Logs Insights allows me to run a SQLite query across my log groups. So running a simple query here to pull out those fields. At this point, it looks very similar to what we saw in CloudWatch Logs. But critically, CloudWatch Logs Insights has discovered all the fields in my JSON structure. So I can now make use of these when I'm running my SQLite queries against the log structure. So here's an example where I've pulled out some of those fields, and immediately, I've got a much more useful set of data here to explore as part of my issue resolution process. And as another example, we can pull out all the errors. I can pull out the correlation ID, which is a field I'm using for tracking all the logs related to a particular HTTP request. And I could add that correlation ID to my query if I wanted to. And then here's an example of an analytics use case where I'm doing a query to pull back all the successful orders. I'm doing a count star on that and grouping it by the last hour. So if I flick over to the last 3 hours for the time frame, we can see the orders by hour for the last 3 hours. So you get a feel for how you can do an analytics style use case for monitoring your business KPIs, like number of new users, number of orders per hour. And then you can add those queries to a CloudWatch dashboard. So here I've created an order analytics dashboard, and I've added that particular query and visualized it as a graph. So that's the end of the demo today. Thank you. I hope that this solution walkthrough and demonstration has planted some new ideas around what your team can do to improve their operational and analytical capability when first getting started. To recap, use AWS CloudWatch Synthetics to monitor your application. Use AWS Commander to manage how your team deals with incidents. Use structured logging. Use the AWS distro for OpenTelemetry for instrumenting metrics and tracing, and then logs when it's ready. And then finally, use CloudWatch Insights, dashboards, and AWS X-Ray to investigate issues. Finally, there is some great content in the field of DevOps from our AWS training and certification organization. The deepest of which is our 3-day instructor-led course, DevOps Engineering on AWS. For more information, visit aws.training/DevOps. Thanks a lot for your time today. I hope there is a great production deployment on AWS experience in your near future. I've really enjoyed presenting. If you enjoyed this talk, please fill out the survey. Thank you.